In programming, it's typical to use variables where we can assign a value, like a number for example, to a variable name. So here we have a list of the variables that we can use in Java. To define a variable, we put the type. So first I'll define a byte variable, and then we give it a name. So I'll call this my byte. Notice that the type is all in lowercase and the variable name is in camel case, which is lowercase character to start, but then an uppercase character in any word. So I define a value for my byte, so let's say 100. Now because a byte is 8 bits of data, it can only take a value in the range of -128 to +127. So if I try and give this byte a value of 128, it gives me an error. If I save that, I can see I have an error. Cannot convert from int to byte because it's saying that because 128 won't fit into the byte. 127 and it's okay. So when we're choosing our variables to use, it's important that we think of whether the variable is suitable for the type of number that we're representing. So a byte is good for this range of numbers, so it may be good for very low values, 1, 2, 3, but if we're going to have a value that can get much larger, over 127, then we wouldn't want to use a byte. The next variable we can use is a short. So I'll define a short, and my short equals 30,000. And the next one is an integer, which is an int, which is 4 bytes, my int. So this can be values up to 2 billion. A long can be very large values. Now all of these values, so I think I have to tell it that it's a long value by putting an L on the end. Now all of these values so far are different size whole numbers. So the byte could go to 127, the short to 30,000, the int to over 2 billion, and the long is 8 bytes, so this is this long number here. So they can be negative or positive, but they have to be whole numbers. The next type we have is a float. This is a decimal number, so we can represent numbers up to 6 or 7 decimal places. Put an F on the end to say that it's a float value. And a double is an 8 byte fractional number. So for that we can represent numbers up to 15 decimal places. Now a Boolean is a 1-bit variable, and that is written as either true or false. So that's just either on or off. And a char is a single character, and we write that with a single quote. Those are all of the primitive types that we can use in Java. What we can do, we can store the value, we could do some manipulation of the value, and we can, for example, system out print line my char. And then if we run this program, it should just output the A to the console. Hello world, I'm still running the old program, so I need to run a new program. Now it's output our char variable to the console. Now strings are a little bit different, but you can think of them for now as being variables. Strings we actually define with a capital S, and that's because a string is actually an object, but we'll talk about what that means later. And strings we define with 2 characters. So I could my string value, and then I'll output that to the console. Now, I'll actually talk about strings in a video on their own later, but strings they're a little bit more complicated than these primitive types, but I thought I'd cover it here because they're very useful. Now if we want to store a list of numbers, we can do this in an array. So if I, for example, want to have a list of integer values, I can put an open and close square bracket, my integers, and then I say new int array, and say how many I want. So maybe I'll say I'll have 3 integers, and then I can index this array of integers by putting the number that I want in square brackets like this. My integers 0 equals 1. My integers 1 equals 2. My integers 2 equals 3. Notice that I've got 3 integers and the index values are 0, 1 and 2. So we index the integers the number of places from the start position. So if we try to put a value into my integers 3, we'll get an error because we've only got 3 available values. We can actually have multi-dimensional arrays, so we could have 2-dimensional array, my 2D integers, where we can, for example, have a square 3 by 3, so we've got 9 different values. We can just index them by putting the 2 index values into the square brackets. Now the final thing I want to talk about in this video is typecasting. If we want to convert from one primitive type to another, we can do it if it becomes a wider value. So for example, an integer is 4 bytes and a long is 8 bytes. So if we say here that we now want my long, we don't have to define the type because it already exists. So we're going to reallocate the value of my long. We can say my long equals my int, and if we system out print line my long before we do this, and if we do it again after, we can see that the first value is the value that we put in my long before, but the second value is the value that we put in my int, and that wasn't a problem. We could just say my long equals my int. But if we wanted to take a value my int, now if we want to take the value my int and put the value of my long into it, it's actually the same value now because I just set it to be the same. It won't let us do that. It's underlined it. It says cannot convert from a long to an int. But what we can do here is we can typecast it where we put in brackets int. So we're saying we want to force this value into there. If this value is too big and it doesn't fit in the int, we'll get the incorrect value. But by doing this typecasting, we're saying that we intend to be doing this. So we're telling the compiler that we've thought about it. We definitely want to get this long value and put it in this integer variable. So that's typecasting. Now, when I'm programming, I don't usually use all of these. So, for example, a byte and a float, for instance. I might use this if I know that I'm talking to maybe an external program that is using bytes or floats. But usually I would just use an integer if I want a whole number. So if my variable represents number of people, for example, I'll use an integer because I know that it's a whole number of people. If it's a number which is going to have a fractional value, I usually use a double. Also, Booleans very useful for true and false values. That's particularly useful when we're doing comparisons of things, which we'll see later. So that's our variable types. Thanks for watching.